Good evening, heroes and heroines, and welcome to Practising Programming in C, where we're continuing to investigate our memory leaks, which we suspect that we have. And in the last stream, we went through essentially the entire program looking for this memory leak, and I think we've just about narrowed in on the source of it. So let me just try and find where that is. Did I write that? Yeah, keep this call next time. Hunt this function down for leaks. So yeah, init neighborhood is the function that we think is leaking. And I'll show you why. Just run the program. So let me just try and eyeball one of these. Right. So there we had a set current project leaks 264 kilobytes. That's this printout here. And then we should have an iteration somewhere. Iteration 10, yeah, so 528. So yeah, okay, so there's an iteration 9 here, which leaked 264. So sometimes it says that set current project leaks, and sometimes it doesn't say that set current project leaks. So there might be another source of a leak. But at least definitely here, we've got this happening here. Leaks 264. So the first thing we're to do is try and make sure that that is never actually leaking. So we're taking the measurement before this init neighborhood call, basically. And then we're taking the measurement after the init neighborhood. And we're saying that this is what we're talking about. So what we need to do is we need to go to init neighborhood. And take our memtest stuff somehow. There is a return here, which is slightly unfortunate, but never mind. What's the function called? It's init neighborhood, isn't it? So doing that is effectively, it should be producing basically the same stuff, I think. Oh, also, one thing I did think about actually, let me just make a note of this. So the free watch handles, do we need to sort of release any handles essentially? possible that we do. Yeah, alright. So let's just run it and just verify that we're getting the same behavior basically. So we've got a leak of something, enabled leaks. So we got, let's just look for an neighborhood leakage. Right, okay. So we got an enabled leak of 264, didn't we? Yeah. Well, hang on. No. This is what I'm talking about. So the got a leak here, 264. So what I'm going to do is I'm going to put a bunch of these get usage things throughout the function, basically. So we've got to get usage there. Alright, so an init neighborhood 1 at that point does that. I mean, I guess we could just stick one here. Very much doubt any of those would be doing anything weird. We've got an init file, so let's do one before and after the init file. And also after the read file into buffer. Strictly speaking, we should expect this to actually be consuming some memory, really. Yeah, we would expect that to be happening. So let's just see how that's doing for us. And I think also, should we make it sleep a bit longer? No, it doesn't matter. We can see quickly. Alright. So 4 didn't leak, 4 wasn't using, but 5 was. So 4, yeah, read file into buffer. So that's the source of our 264K. Reading that file into buffer. Now, this file should be being freed. It should be being freed both by discard all and free config. And it should also be being freed by the function that was called by us, that called us. Yeah, free file. So that happens there. Init neighborhood. So this is the thing that is leaking on a loop, essentially. I mean, I suppose another way of doing it is just to say, free that file right here. Okay, yeah, so it seems like that's correctly never actually erroneously set to something, basically. Let's have a look for another read file to buffer DB file. How does he do this? It's not that. Oh yeah, isn't it something like you can yank and then do this? Nope. So this is the call we're talking about. This one up here is the one that's consuming the memory. We're not coming to here. This is in reinserting, isn't it? Sorry, in insert into DB. And then this is going to be the complete initializations to delete the DB entries. Init file. So it sort of seems like that ain't really a source of a leak, really. Yeah. So unfortunately, I think that we've gone through all of the places where we could have an explicit memory leak. I think. And also, like, remember, so in iteration 17 it leaked 264. So that was iteration 16. So let's just look for leaks in Init neighborhood. So they should colorize these printouts actually. But yeah, you can see that none of those actual things say that Init neighborhood leaked. Like none of those were the cause of this 264. Which suggests that it's actually somewhere else. So I suppose we just continue looking for the thing, don't we? So back this stuff out. So yeah, we've got through to set current project. That's called by sync project. I mean, do we just continue? Who else calls that? That's called by, this is monitor system, yeah. Right, so we've done the template freeing. We know that that's freeing stuff correctly. So then sync DB with import. Let's time that. So that's apparently leaking 264, which is the same amount, isn't it? So on iteration 6, that leaked 264 in total. Yeah, and sync DB with input was responsible for that, I think. So I think there's our culprit, actually. Let's just do a little macro for this thing. That should be okay, shouldn't it? Yeah. And then mem test. Can we mem test prior, mem test after, actually? Well, English is fine. Alright, so actually what we want to do is to just take these guys and stick them inside sync DB. Right. So we've got synced with input, actually calling that now. We do need to have a mid one as well. But we'll get there. So to do a mid, we just want to say oh, right, yeah. That's great. Well, actually, because kit usage should be the same value, shouldn't it, really? Nah, let's just leave it as it was, actually. That should be fine, because basically this is going to sleep after you've done the thing. Might make it sleep a bit longer, actually. Well, sleep 2. And then basically the idea is you just sprinkle these mem test mid around between the initial and the after. So we've got a loop there, actually. What's it initialize? It initialize the pointer. That could be a source of problems. All right. I'm just going to get this going and just leave it running while I'm just go away for a momentary pause. So we're using 26 meg now. So yeah, what's that after 45 iterations? We're using 27 meg, that's way too much. And it's going to be due to the fact that every iteration we're leaking some amount of memory. Hey Serge. Yo Joe, say hello. Fantastic. How's it going? It's been such a long time, dude. Probably has been a year. Yeah, let me actually just restart this song because I nipped off when it started. This is probably my favourite song by Kate Bush, maybe, I don't know. I really like it, at least. So yeah, 264. Just get a read. I'm alright, yeah. Yeah, I've actually moved house since we last spoke. Some of this new place, which is an absolute fridge freezer. It's really cold. Yeah. But anyway, what we're learning is memory leaking. It's basically trying to straighten out some memory leaks. Because what I've been doing is I've got this config files kind of written, config file processing thing happening. So here's an example config file. So obviously you need to parse it. And one thing I've just recently done is making it so that when you resave the config file, the program actually picks up the new config and it's supposed to discard the old information and kind of reinstate everything, basically. And since there's that thing going on, since there's the ability to like discard and reload, I think that I need to make sure that there's no leaks happening, because basically the program can just remain on all the time. It can run for years. And in fact, I think Cinera has been running probably for about a year since the last update. But now that we've got the config going on, you know, you can just run it, and whenever you want to add a new project, for example, you just add it to the config, and the program's supposed to just pick it all up. Yeah, and really, I just want to make sure that it's just not leaking any memory, which it clearly is. You know, it's clearly leaking 264 kilobytes every iteration, and I'll just show you what an iteration actually is. So what we're actually looping on is this. So I'll go through from main. So you come into main, and the first thing you do is process the command line arguments. You init the memory arena, so we give it 4 megabytes. We get the config path from the it's the command line argument still, and then we come through. We then claim these buffers from the memory arena. We initialize the iNotify instance, and then what we do is we pass the config. And then if we do get a config, we rewind the collation buffers, which is something you need to do. And then we init all. Okay. And then having init all, this thing here is supposed to be free. The stuff that init all does and that parse config does is supposed to be freed by discard all and free config. So it's discard all and free config, which we're actually testing now for the leaking. And all it's doing is it's looping on this thing, calling this and then calling parse config and init all again. And the memloop free macro is just in the loop. So that's basically the thing that's responsible for outputting stuff like that theatre 145, this line here. That's just what this is. The memory post is responsible for printing that, and then sleeps before. And discard all and free config is doing these things here: free signposted file, free assets, free reset count of the watch handles, sets the current print to 0, and it frees the config. And I've gone through it. I've determined that all those things are actually okay. Like free config is not leaking. Free file, these two guys aren't leaking. Free assets isn't leaking. Now this thing here, we don't have a note for it. I think that's actually with good reason, because I think I actually possibly need to do something more with watch handles. Maybe I need to release some iNotify watch handles. That's something that I want to look into. But let me just show you something really weird. I don't know if you know about this, because you're more familiar with, well, you're a better programmer than me. So if I just F0 this, so I'm not going to be doing the thing, and I'm just going to parse config. Could be links to fragmentation using arenas, which I think might be very much. Could it? Well, it could possibly, I guess, yeah. I don't think I'd thought about fragmentation. I'll make a note of this. From search. Yeah, let me show you this first. So, right, what I'm going to do is I think we're just timing tokenize, yeah. this might actually leak a little. No, it's not. So I think the reason it's not leaking anything is because I've forgotten to actually make token items do something. Yeah, so it's not pushing the config watch handles. So that's something that needs to happen. But when I'm testing the freeing of the template, freeing of the tokenization, I can't do this because something else has to be responsible for freeing these watch handles. But anyway, so this isn't leaking, right? After 65,000 iterations, it's not leaking. But if I do this, if I do free tokens list, if I do right, if I just do that, I was finding that I was leaking 24 megabytes. Well, wasn't I finding that I was leaking 24 megabytes? I mean, I'm certainly leaking something. Oh, beg your pardon. This is only after, yeah, this is only after a certain few number. So if I just let this actually happen all the way through, right, without sleeping, right, we get through 64,000 iterations. And we're leaking 24 meg, right, just from doing this. Which is something that I hadn't anticipated seeing at all. And basically, my understanding of this is pretty hazy. But I mean, it's something along the lines of, my reasoning is kind of like, because I'm setting this to something inside a loop, so the loop is this mem loop thing, and because I'm passing this to a function, it's having to keep around the memory. Just in case he was going to have to use that value again. In light of the fact that it's changed it. But I really don't know. I mean, it's, I don't know, like something to do with initializing this. So obviously when you initialize this, it's going to take up space on the stack, isn't it? And then you set this to be the value of that, and then pass this to a function. I think that seems to be the case that's problematic. And because I'm doing it in a loop also, I'm doing it in this mem loop, it's just getting a bit leaky, really. I think was there another thing I wanted to say actually. I think I wanted to see if I were to just printf it actually. What is this again? So if you just print the count, for example. So now we're not passing it to the function, and I thought that was one of the key qualities of this thing. Yeah, and it's not leaking anymore. So it's not necessarily, it's not only to do with initializing that. Now let me just see, again, if I do the tokens list, if I just do that, now free tokens list already does that. So it's already operating on it. But the thing is, the tokens list is not initialized inside this loop. Which I think is another aspect of it. Yeah, again, this ain't leaking. Yeah, so originally, right, I used to not actually pass tokens list to this function. I used to actually go like this. Right, I used to do that. Okay, so we are passing that in, that tokens list 1 in, but the thing we're actually using is the tokens list variable. Yeah, that's not leaking now. Oh, yeah. So we're not actually. Again, yeah, we're not initializing it within this loop. We're not initializing within this loop, but the loop that we were initializing it in is the parse config. This one basically. So this is doing the full config. It does the free config and then it does the parse config, and it's parse config that we're talking about here. So I think this is going to leak as it used to do. Right, yeah, it's not. Oh. Hold on a minute. I think I didn't save that, I think. Yeah, so there you go. So that's now actually leaking. Right. People are looking at someone's user got to define it. Define, I said condition do. If it was something. Oh shit! Yeah. The yes. Very good point. Yeah. Let me fix the assert. Yeah, well spotted, blimey. Yeah, the do while thing. Yeah. Yeah, do this if it's that, isn't it? Yeah, good point. I had stumbled across that at some point actually, but for some reason I hadn't done it in here. Let me just double check actually that I've done that right. So do, and then we if. Do the stuff. And that corresponds to the do, and it's while 0, yeah. So I think that's right. So yeah. So yeah, as we saw, using this tokens list that was initialized within this loop actually yields a leak. But if we do not do that, so we're instead initializing our tokens list here and passing this in to tokens list, and then, sorry, we're passing this tokens list into parse config. And similarly, we're passing it into the loop here for it to be used here. If we do it that way, I just wanted to double check that I'm actually building the right thing. We leak a lot less. So we do still leak, but we're leaking a lot less. I think after like the 13th or 14th iteration, it would have that 700 and something kilobyte leak, but it wouldn't leak enough to end up leaking 24 meg basically. And it's not like a heap allocation either, is it? It's like it's just a variable really. So that's just one thing that's kind of that I've stumbled across. And I don't really have a properly good idea as to what's going on really. Yeah. Let's take a look at this to do the inputs thing. Just turn off the this loop. And just take a look at what this is actually giving us now. So oh, we need to actually loop, don't we? We do need to loop somewhere. Yeah, it's the discard all free config is what we need to actually be looping on. So yeah, that's 264. Try keeping in my head the fragmentation question as well, actually. Actually, let me just loop until we've got one of the iterations leaking. Right, so iter 3 leaks 120, apparently. And there we have syncd with input leaking 120. So we come into syncd with input, the 0 kilobytes, come through 3, we do all of this stuff, and then having got out of there, it's down here. So between here and here, I mean, we've got a reset neighborhood in here. guess actually we can just get rid of the 1 and the 2, I reckon. So we say 1 is there. Let's say 2's there. So it's somewhere between those two places. And let's just say that we've got a 1A here, 1B there, 1C there, and 1D there. Now let's see what we're presented with. So iteration 3, apparently the leak's 112 kilobytes. Sync deep with input, so yeah, 112. So we've got 1A, oh, we're in a loop. Yeah, we are in a loop. So at 1B, we were using 0. We reinsert this, and then yeah, then it's consistently using that much. So what was it? It was A and B are fine. So there's nothing wrong with reset neighborhood. So I guess I could get rid of this. Yeah, it's just the insert entry, isn't it, really? That seems to be our culprit. Actually, let me just have a quick look at that first iteration. Well, let me just do the full iteration. Yeah, it's going to be the first initial init, isn't it? So that's saying we're coming to this using 0 here, and at 1B, which is after the insert entry, we're using this much, which sounds fair. Actually, it does sound fair. Because it has to allocate the collation buffers search thing. Yeah, now we've got fetching quotes here. So we figured out that the fetching quotes does the curl call, and curl itself uses some memory to actually do its thing. And I think we determined that we were okay with what that was doing. Let these values all the same. Until here. And at playing with the Fedora change root, that then uses up another 400 kilobytes. Until eventually 5220 So there's got to be something in insert entry, I think. Let's go into insert entry. And let's just do the thing, I guess. I mean, I do think that I've gone through these guys actually. But got it after. Is it actually 104? Yeah, so really what should happen is we do insert entry to DB. So that should happen. This should do a HTML to buffers call here. That does that. And then somewhere there should be an allocation. For the search. Is it the search? Yeah, I do think it is the search. We're way out of the function now. Well, surely there's something to do with size, isn't there? There's an allocation, but this isn't the function. Yeah, it's not the right function. So where is that? Where is that happening? Somebody has to be allocating the memory to actually contain the something. Well, hold on. Doesn't the collision buffers just tell us who it is? Yeah, so this buffer is marked separately rather than claim for memory search. Yeah, now we're into a different function again. Buffer to HTML. Yeah, I'm pretty bamboozled now as to what's going on. Because surely this has to actually get some memory for the search buffer. Oh, actually. Oh, it might actually be generate it's the other function. So it's not HTML to buffers. Yeah, I think it's not this function. It's actually, if I just go back to insert entry. Well, it's the person who calls insert entry. So we do the generate player page. The person who calls insert entry is here. It's generate search pages. This person generate search page. Buffers HTML. Well, it's search to buffer. This is the thing that will actually, it takes the collation buffers. And at the very, very end, it basically masters it down into the search buffer, I think. Append buffer, so the index to the B. So the B, I think, is the search buffer. Yeah, Jesus Christ. So there's our person. There's a collection buffers search. And appending this buffer actually does a reallocation. Yeah. There we go. So there's our actual allocation within there. Right. So that was within yeah, in fact this guy doesn't even do it. So we were just looking at this, weren't we? Insert entry. Yeah, so it's generate search pages that actually allocates. Allocates for that, yeah. So the thing that we were looking at, insert entry. Right, it was between A and B, wasn't it? Yeah, it's the first time through. So yeah, it does the reinsertion. So between A and B, we consume 6228. And between A and B, that was not the actual search buffer. That was not. It wasn't that was being allocated. So I guess we just go through, don't we? point in measuring those guys actually, because I happen to know that there aren't any bespoke templates in Risky. Let's say that that is also, well, let's not just call it 6, just so we can distinguish between them. Yeah, so that's everything. Every single line is going to be covered by that. So we run. Seem to be with input A. Insert entry. So yeah, insert into DB is a conceit. I suppose I should actually put 0 before that, I suppose. Yeah, so that doesn't, and then consume 528. Final, is that what I called it? I can't remember now. No. Initial. After. There's a big H out of buffers. Cool. Let's just stick one around them. Let's put 0 at the top. So between 2 and 3, yeah. So H1 buffers, it's consuming 528. Now, I mean, that could be due to the, yeah, I mean, the quote thing is going to actually be sort of leaking. So what I'm going to do is I'm just going to let this run. Because it's got to use some memory at some point. So iteration 3 leaked. Yeah, let's just go to the next iteration. Well, alright, so iteration 5 has leaked 264. So what's the source of that leak? Sync DB with imports. So it's iteration 5 that we're looking at. Right, so there's iteration 4. Should see a red thing pop up. Should see one red, I think. So there's a red. 264. There's a red of 264. we've finally, after all that, we've used 264 more than we started off with. So we've got 2 apparent leaks. Both are 264k. Insert entry 6 is one of the culprits. So between 2 and 6, so we had 2 there. We weren't consuming more, but by 6 we were, so that means that link neighbours consume 264 meg. Okay. Oh, insert enable link will be some substantial stuff. So let's just see. Let's just put some things around this. Actually, now think about it. Well, yeah, let's do that. The chances are we'll see that one of those will cause us to sleep. So link to new entry 1, 2, 3, 4. Yeah, that's 116. Just wait for the next iteration. So there we go. That's that happening. So sync with input there. Oh no, hang on, inserted to DB1, let's just prevent those from printing. I suppose I could do some if-defs, but yeah, won't bother. Oh, I did the wrong thing, didn't I? It was inserted to DB. That was the thing I wanted to actually delete. Oh, right. All right. I suppose it could both have gone for all that. So yeah, we're just going to the first iteration that leaks. Oh, the next one. So iteration 3 is leaking. Now, sync TP with input. had got a leak, and we wanted to be looking at link to new entry, wasn't it? There we go. So at 1 it wasn't consuming anything. Insert neighbour link, after that it consumes 112, and that remains consistent. So this seems to be some of our problem. Test initial. Do we return inside this thing? We do return here. And here and here. So we've got free file of close. We have got free file. So we do the initial, and then we do that. So then we really want to be doing like the mid ones sort of throughout here somewhere. So let's just do them. Just double check about this. It doesn't take a string. No, it just says the initial. Actually, let's do that as 0. So that's just the start. I suppose I keep doing that, don't I? Get usage, take away initial. I mean, that's always going to be 0, isn't it? If I call that first. So I guess technically you don't really need that. I mean, clearly, read player page into buffer is going to consume memory. So I should expect this thing to actually print something. I guess another way also to do the printer would be to only print it if it's non-zero, basically. So that you're not left with a bunch of stuff that's printing and just clogging up your buffer. Alright, let's get to the next iteration. Iteration 3. So we've got 108. So sync DB with import, we've got 108 there. But, I mean, that's probably encompassing more stuff, and it seems to be encompassing more interior stuff. So yeah, link to new entries. So link, insert to neighbor link 1. Yeah, at 108. At insert neighbor link 1, we continue 108. right, which is basically what we kind of expected. The thing is though, after we've got out of here, we want to have freed that file, basically. File path. So yeah, constructing that does actually allocate some memory. File path. And the thing is, we have done it as a free file, which frees the path. So could it be handles then? We've got an fclose of handle there. Read play page into buffer. If we haven't got a handle, construct that and read that into the buffer. So that opens it and it closes it. Right, opens it, reads into the buffer, and closes the handle and sets the handle to 0. If it's got a path at all. And it is talking about, oh, hang on. I mean, there is this. But surely it knows that by the time we get, oh, hang on a second. Oh, is this a case of us passing this? Yeah, we do pass that to there. So it could be one of our implicit memory leaks. This HTML handle if2. So how would we have the handle still sitting around? Right, we get in here. Right, we initialize HTML here. We read the file, read that into the HTML variable here. And we close the handle having read it in. If you've got a buffer at all, then that's how you can get into here. If we don't have a handle, which we're not going to have because this guy closes it. Sorry, wait. If what's that saying? It's saying if we don't manage to open that writable, then free the file. Turn over file. Okay. So it's trying to open it writable. All right, I see. So it opens that writable. Beg your pardon. And then it writes the stuff. Yeah, that makes sense actually. So having written all the stuff, then it actually has to close it. Just imagine that's it. Surely it's not going to be that. Did they actually build that? It's not done. So what I'm looking for is insert neighbor link. Yeah, it's enabling links 0. So let's just get to the next iteration. So it's now leaking 104, which is less than it was leaking before, because it used to be leaking like 200 and something, didn't it? That is bizarre. If that is all it is, then that is unfortunate. Just go back to see where we've got some red, to see deep everything put. Again, that's probably in it, and like a exterior thing. Insert entry. Okay, so we've got insert enable links still leaking, apparently 104 KB. Yeah, I'm just wondering about that fragmentation thing. Like, if you don't initialize stuff to 0, and there's just stuff in that in those bits of memory, I wonder if that counts as fragmentation. Like the kernel decides not to free up that memory, maybe. See if that makes any difference. I think I would also like to just go back and not set that handle to 0 at some point. So a lot of that is going to be due to the quote. Going to be due to curl, I reckon. I think we're going to get iteration 3 next. Yeah. So yeah, 104, if I just don't do this, right, let's go back to how we were. So we were like this. We were inserting that to 0. (104) is what iteration 3 was saying it was leaking. 104. Alright, so it's 112. Yeah, so it's not exactly made an awful lot of difference. Yeah, I mean that's probably not related to what I did actually. But I think it's good practice actually to set the handle to be 0, I think. Iteration 3 coming up. Yeah, 112. And the source of that is insert enable link 1. So reduce the replay and player into buffer. Just give me 2 minutes, and I'm going to do something absolutely ridiculous. What I'm going to do, basically, this might not help, but what I'm going to do is I'm going to initialize this HTML file way outside of the whole, well actually I'll probably just initialize it globally actually, and then just make this use the global HTML file and just see if that makes any difference. But just give us 2 minutes, we'll be right back. Alright, I'm back. It's now 10:30. I think I might like to try and finish within the next half an hour. We'll be going for 1:41. Let's get half an hour's more music on. Let's just pull the limbo on, actually. It's 20 minutes or so. And then basically what you want to do make sure you're actually using a free one. So I think, yeah, I can't actually do that, can I? I can't really. Well, I suppose the free file just needs to make sure that it actually frees the file, doesn't it? So it's freeing the buffer and freeing the path. And what else have we got in a file? Handle. Yeah, right. Yeah, actually, is that what I actually want to be happening? Because when I free a file, what we're talking about doing, yeah, it shouldn't hurt, should it? I don't think. To also just to set that handle to be nothing. Because you want them to be opening that handle when you're reading and when you're writing. When you're reading it in, you the read function actually closes the handle itself, and when you're writing, you're not going to be wanting to free the file while you're still in the middle of writing, are you? So I think you, within your rights, to set that handle to be 0. The path we're freeing. The buffer we're freeing, and free buffer. Should be it frees the buffer location, sets the point to the size of the ID to nothing, and the ident level. I guess we could set that. Indent. Just double check. Indent level. Yeah. So what doesn't? Yeah, you can't do that. So basically, the free file that this function itself actually calls. Right, so it's going to start off. It's only this function that uses the global HTML variable. Why didn't this get changed to the global? Oh, I know why. Just, oh god. Let's try that again. I need to do the G at the end. Yeah. So yeah, like I was trying to say, it's only this function that uses the global HTML variable. It needs to start off as nothing. Free file now actually does all the stuff that it needs to do to get it to an initialized state. And the places that we're returning here, we need to free the file before then. Free the file there, and free the file here. So yeah, I think that now we're fine, I think. So it's a bit of a guess, but let's just see if this makes any difference at all. And essentially the difference here is that we're only initializing the global HTML once. Right, we're not initializing it within a loop. And the reason I was suggesting that seemed to be a problem for me was because, or to me rather, the reason it seemed to me to be a problem was that you were passing that variable into functions. So you were initializing the thing within a loop, and then you were passing that variable itself into a function. I mean, that seemed to be the thing that was triggering the tokenized thing to be leaking. Just make sure I'm on the right scene. Yeah. So let's try and get ourselves to iteration 3 and see how much that leaks. So we've got iteration 3 leaking 112, and that is caused by syncdb with input. And it's enabling, yeah, so this is still consuming, but the thing is, oh, hang on, insert enable link consumes 112, yeah, sorry, so here it uses 112, and by the time we actually get to the end of the function, we haven't freed up all the memory that we needed to, or for some reason we're still consuming 112 more than we started off consuming. We're consuming 112 more than we were consuming before we did the read play page into buffer. So yeah, that global HTML thing doesn't seem to have done anything for us. I mean, we just go down the turtles, isn't it? So let's just get rid of that. And go to here. So mem test. I mean, the thing about this is that it actually, we should expect this to be consuming the amount of memory needed to contain the FAF. So, you know, technically we should actually find that this is actually using more. But I guess what we should be finding, really, we could test this in another way, right? Read play page into buffer is the work that we want to be doing. Right, memory loop free. Free file. Mem loop pre-work. And then finally mem loop post. And this was for free file basically. So we wanted a string also. Oh, right. What did that like? Oops, sorry. New mem loop. That should be okay, I think. So what this is going to be doing is looping on the actual freeing and well, it's just the freeing of the file actually. It's looping on. So we're going to have an exterior loop, which is still the main work, and then we're going to have an interior loop, which is this one here. I mean, I guess same deal. Only print out the iteration if it leaked. I mean, the only difference now is that we're not printing out the stuff. Oh no. So after 64,000 iterations, if you remember the first time we did it, it reckoned that we were losing 32k, wasn't it? Alright, man. You like my code? Oh, cheers. I'm glad somebody does. I quite like it as well. Yeah, I mean, I like some of it. I think I like the config code a bit more. I think I like my more recent code more. I mean, the stuff that I've been going through today has been quite old code actually. So it's been quite naive, because I was still working out how to do all sorts. I mean, even these macros now are completely like a new sort of a new thing for me. Like I don't really do an awful lot of this, but yeah, it's cool, and great to see your name. So yeah, take it easy. And don't be a stranger, man. I suppose I'm as much to blame for being strangery, actually. But yeah, 160k. Now it's nothing. It's still nothing. And it's still nothing. It's the first time free file consumed. Well, after the first loop, it consumed 40. Let's see if that's also the case when we put the if back in. So we're not going to be printing out all the iterations. Because basically, I wonder if it's just a problem of us. Oh god, what? Consuming memory just for the benefit of for the what is going on? Shouldn't that be what's going on? If that. Iteration. It shouldn't be printing out all the time. If memory loop new is go to the memory loop initial. Oh, and also because now in the same test. Oh no, that's not the test actually. The test that I actually want is not sorry. I did beg your pardon. It's memory bold. That's what I want to be testing on. Yeah. Jesus Christ. We're getting there. If memory loop new is greater than memory loop old, yeah, I do think that plus is actually garbage, but whatever. Maybe I need to just do that because it's more than one call. Alright, yeah. So the first time, iteration 0. 2, 3, 4, 3. Yeah, so the first time it consumes 44k more. Doesn't that seem a bit of a large number? Let's see if that's affected by the number of iterations that we're doing. 44k. It's not 40, just do it again. No, it's 100. So yeah, it's effectively random. I'm going to say that free file is alright now. We don't need to do the handle because free file itself will do that. Alright, yeah, so we're not testing the free with the file because we're assuming that that's okay-ish now. So yeah, iteration 4 consumed that much. Iteration 5 also is using more than the previous iteration was using. Let's just let iteration 8 get there. So 264. First insert entry leaked to nothing. So here we are in iteration 7. That was the previous one. So now in iteration 8. We do these things, none of these guys leak. We yeah, so do that. Get through here, none of these guys leak. We do that. Get through to insert entry. We find that insert entry 8 the generate player page has caused us to use 264 more than insert entry 7, and as a result insert entry has ended up consuming 264k. Player path. There's our free buffers of the search. If there's search in the template, it's only occasionally that thing actually consumes more. We have got another reset asset landmarks here. See what is that? for each asset gives a free and reset count of the player and the landmarks. And so the offset landmarks to false. Should we just do this function quickly? Just break this down, see if we get anything. So we need to do one before here. And there could be one there, but I don't think we're actually hitting that problem. So we're looking at generate player page. So generate player page 5 was a culprit. So buffers to HTML. So between 4 and 5 we've got buffer HTML. So let's just do this, I guess. Right, so it actually returns within the function. Oh god. Right. So I think that was them all. Hold on. Nope, this is the same function. Right. So basically we should expect to see the buffers to HTML. When we find that generate player 5, we should be seeing basically this person, buffers to HTML, popping up before generate player page 5. Yeah, so there we go. Buffers to HTML leaks 384k, and then generate player 5. Right, so now we look into this now, where this is actually where this is leaking. Gosh. Mem test mid buffers to HTML 1. So I think we can ignore the template thing because I don't think that we're talking about people with a template. No, we do have an allocation here. It's 512k. Oh right, this is the first mid one, is it? Is that true? We're saying we're not doing a mid until there. I wonder if I should just do a macro like the free macro that closes the handle and sets the handle to nothing. Oh wait, the after one is already done, isn't it? Yeah, there's the mem test after. So I don't necessarily need this at the end. So let's see if any of these actually indicate where the difference is. Buffers to HTML with a number. So they're saying 8. So between 7 and 8, buffers to HTML leaks 444 blinkamajigs. Or it consumes 444k. What is the master exactly? Yeah, the fragmentation thing. So I guess you get fragmentation. So this time, interestingly, after callocking it, it immediately says that I'm consuming 436, whereas when I wasn't callocking, it took until one of these. It took until after 7 and before 8 before it reckoned we were consuming. So that's for the master now. We are freeing that master though. $436k. Where's 3 again? So 3 is here, so yeah, again, like the calloc of this. Right, if I just refrain from callocking it, let's do a regular malloc. Buffers to HTML3 is what we're looking for. Yeah, so buffers HTML8 is the first one that starts to apparently leak. Let's just link it to this address. Okay, so there's iteration 3. So that person consumed 112 more than it started off with. Sync DB with import. So these guys individually do not leak. The guys in blue. This time it's sync DB with input 1b. Sorry, no, it's insert neighbor link 1 is the first time, I think. 112. Insert neighbor link 1. Read player page into buffer. Yeah, we've already looked at that. So that consumes, and when we get to the end of the function, insert neighbor link. Oh, hold on. Yeah. So we get into neighbor link and take a reading. By the time we get to 1, that's using more than we were originally using. And then by the time we get to the end of the function, we are still using 112 more than we were using at the start of the function. Is it still running? No, it's not. How do you actually do this? Basically want to be defining something that does basically nothing really. all I'm trying to do there is to allow me to toggle that on and off, basically. Oh, hang on. No, can't do that. I mean, maybe what you have to do is to sort of include stuff. I don't know. I mean, I would have thought that if 0, or rather, if you do if 1, you're not allowed to do that. Whatever. So, iteration, yeah, so all these iterations are actually consuming 264k or 528. I am going to call it a day in about 10 minutes. fragmentation. So, my understanding of fragmentation is when you've got allocations happening in various bits of the heap. And in order to actually allocate any memory, so you're allocating bits from the heap. Allocating this from there, that from there, that from there. So that is in effect fragmentation. So you've allocated, freed, allocated. Yeah, maybe that's what it is actually. Could it be that when you do a free, that memory actually cannot, it ends up being used in a way that it can't be used in its entirety? I wonder if that's the problem. Because I have got a mixture of arena allocation and bog standard heap allocation. Let's just have a quick gander. Let's get Firefox open. Yeah, this is what I was sort of envisaging. Yeah. Yep. Yeah, I understand that. A collection of data in memory. It occurs when a collection of data in memory is broken up into many pieces that are not close together. Can we do this again? So internal frag is when you wanted to allocate less than a page, basically. Program to draw multiple of 4. The 8 on it. Right, so that's internal fragmentation. And external fragmentation was when you've done frees that are too small to contain a larger allocation that you desire. Where are we at? So now using 30 meg. £31 meg. Well, it's about time for me to call it a day. I wonder. There's 2, there's 3, what is one? I wonder if I want to get rid of all of these miniature allocations. I mean, this is a fixed size, like it's 512, so that should be able to satisfy that allocation without having internal fragmentation. But I wonder if what we should do is we should move away from these like piecemeal allocations and just try and move everything over to use memory books, because we already have the idea of memory books in the program. The config system uses it. So yeah, I wonder if we just do that and see if that makes any difference at all. And I mean, even if it doesn't make any difference to our apparent leaking, I just think it can't really hurt, really. Then these guys, these extend string 0. Right. So this is a thing that's in the config thing. Extend string in book. Right. So rather than doing as the other guy was doing, it was just allocating, it was reallocating whatever it required. Like it wasn't fitting it to like a nice amount, like multiples of 4 or whatever, multiples of 16. It was just fitting exactly what it needed. In contrast to this version, the actual extend string in bulk will just allocate, it'll get an entire page, like if it can't fit the string into the current page, it will get or add a new string, get to add a page for the string, and a page is like a fixed size that we just say is going to be some size, probably a kilobyte or something. Or whatever, kilobyte, 4 kilobytes. And then we just write our strings into that. And then once we've done with the whole, with all the work, rather than actually having to free strings individually, we should just be able to free the book. You know, you just wipe the whole book clean. Or you could just leave it, you could wipe it clean and just leave it the size that it ended up as, I guess. I mean, maybe that could help. I'll tell you what, actually, before we go, how long are we going? 2 hours 48. Alright, let's say we've got 12 minutes left until 3 hours. Let's have a quick look at these watch handles. So, I notify. We've got init, yeah, right. There you go. I notify remove watch. So what does that do exactly? When all factory items have been closed, the underlying objects and its resources are free for use, but all associated watch automatically. Right. So, yeah. This is something we need to do, actually. Go through all the watches and just close them, I think. And it's saying all associated watches are automatically freed. It removes an item from an iNotify watch list. So let's just take a look at this. So this is iNotify watch. And it's pushing onto the iNotify instance. Yeah, we should just be able to, I think, we'll just simply leap over the watch handles. So we're going to discard all. This free raise account isn't sufficiently free. It's just like So it's the descriptor that you need to close. Also, remember that thing I wanted to do? Does this actually do anything at all? Now again, let's just go back to the iNotify thing. And it's saying iNotify remove watch from removes an item from an iNotify watch list. Remove an item from an iNotify watch list. Taking a file descriptor and a watch descriptor. So it removes the watch. So okay, so it's taking iNotify and then it's taking the descriptor. So first of all, it's the iNotify instance, and it's wanted to take probably a pointer to that, isn't it? No. Let's check what this actually does. It removes an existing watch from an iNotify instance. It removes a watch. Removing a watch causes an unignored event to be generated for this watch descriptor. So okay, so we ignore them. And then close that handle. Also says I know return 0. On error minus 1 return error number set to indicate the cause of the error. Okay. Let's call it remove and free. Alright, so let's see if that even runs now. We need to actually get through an iteration. Well, yeah, here we go. Testing full fresh config freeing. Oh, so there's no iterations yet that's leaking. Oh, dude, is that it? Currently using 23.604. Testing full fresh config freeing, and apparently it's still doing it. Oh my god, if it's actually doing it. So we just prevent it from testing that. Now we are going to take a while to get through the first iteration because we can't really easily turn off these things here. Oh, did I not build it? Just hold on. So that's what it was like. Let me just do this. And now let's just say I assume it's just that function that's not going through. why that should be a problem, I don't know. Hi there. Hi. It's the second time round. What are we not doing right? Watch handle this. Now in closing a watch handle, are we just supposed to do that? Because I notify gets rid. Well, that was unfortunate. So what's the count then when we get down to here? I mean, the count's going to remain the same because that ain't going to touch it, is it? I mean, it's the basic idea. That it's just popping them off. In other words, I should be doing something like I guess another way would be to say that might not have been the right initialization actually. Well, whatever. We got a descriptor. We're getting it. We got it high. Doesn't like trying to close that descriptor. What is the problem? Why does that fail? Yes, a file description. Didn't expect this to be a problem. Try removing it instead. Just double check what we're talking about here. We're talking about just ints in FD and int WD. The identifier instance is an int. And this is an int also. So that's all we're talking about. So that's fine with it. Iteration is still consuming though. Oh, I suppose I actually need to close the actual identifier instance itself. So maybe what you're supposed to do is remove the thing, just remove those, and then when it's saying when all file descriptors is referring to an iNotify instance. Okay, fine. So iNotify remove watch removes an item from an iNotify watch list. So that removes, and then let's just say this descriptor is equal to 0. I think that should be fine, shouldn't it? And then having done all of that, I think actually we do want to keep the iNotify events actually open. Sorry, the iNotify instance actually connected. So maybe this is what you're supposed to be doing. Right, we're removing the watch handles. So the iterations are still consuming. Moving through watch handles. Also, I suppose you could sort of say this. Although, since you're going to end up freeing, double check. Yeah, like project is fine. That's just a pointer. It's not actually an allocation. Yeah, I don't think you need to zero it out because we're freeing and resetting the count of those watch handles. So yeah, all we need to do is just remove that watch. Actually, yeah, but it does seem to have not helped us out really. Pretty consistently, after the first couple of iterations, we're just leaking 264 or 4 or 628. So yeah, let's just call it a day. 3 hours 14 we've done. Let's call it a day there. And honestly, I think the next time I think I'm going to have to think about this until the next stream. And just come up with a rationale behind what's going on. You know, because we are kind of consistently leaking 264 after the first iteration. After the first few iterations. And the 264 is actually coming from something that we sort of know about. It was coming from buffers to HTML, wasn't it? Or something. Get to one of the iterations. Iteration 0, 1 and 2 seem to be fine, or iteration 1 and 2 seem to be fine. This is iteration 3 happening, so that leaked 112. And yeah, well, syncdb with thingy. So that time it was insert neighbor link, which yielded the leak. And that was after doing the read into buffer. So for some reason reading that page into that buffer left us in a situation where by the time we actually do the mem test after, we're still using all of that memory. So yeah, I guess we try not to use malloc, I guess. I think that's basically the story, really. Yeah, just try and switch in memory box. And then we're working in regions of memory that we know we've allocated. That we know we can free, no problem. And that we know are sort of consistent sizes. Yeah, I mean, that does kind of seem to be the way to do it, really. Yeah, maybe we could start next time. Let's intend to switch to using memory books for, well, for all of our allocations, really. For all of the places where we're allocating on the heap, switch to using memory books. Let's intend to do that and get a feel for how much work that'll actually be. If it turns out it won't be an awful lot, then do it. If it turns out that it will be a lot, then I wonder if we should actually just postpone doing that. Get this release out. And then work on fixing this stuff. Where are we? Mid-January. I'd like to have this release done by the end of Jan, really. And what we've got left to do is the template stuff. We do also have the sort of initial config loop thing. Yeah, we do sort of have that. Which will be a piece of cake. It wouldn't be an awful lot to do. That config loop. Yeah, then it's the template after that. And then it's just really cleaning up and making sure that we've got all the options that we actually need, really, in the config file. So yeah, as I say, it's not an awful lot. I don't know. Let's see. Tomorrow, let's begin by scoping out how much work it'll be to switch to memory books. Let's do that as a minute. Right, that's basically it. we've got to make the resolve variables handle the tilde for the home. Oh yeah, that's segfault when adding bitwise to the config. Need to have a look at that as well. Does tokenize actually call it? Straight out of Init, by the way, that's what I was talking about. See if this makes any difference. I would expect it to be leaking a similar amount. But who knows? I think this is still the first iteration, yeah. So 0, 1, 2, they weren't leaking, just as normal. And then 3 starts to leak. 4's leaking. Yeah, so 0, 1, 2 are fine. Yeah, maybe so just got it. It's a fragmentation issue. So the first 3 iterations are fine because there isn't so much stuff being allocated. But once you started to allocate, you can start to fragment. I can buy that. So yeah, that's it, definitely. So 24. So thank you very much, Heroes and Heroes, for being here, for being memorable, for being clean, for being continuous, and for being methodical. So until next time, farewell for now.